Good afternoon, everyone.
Good afternoon, ma'am.
Okay. Acha. So today we will discuss about the interval estimation. Means uh, by actually what we do in this chapter, theory of estimation. What we do, we estimate the population parameter on the basis of sample. So in interval estimation, we uh, we take some interval values in between which the probability of the population parameter is highest. That is called the interval estimation. So, if you have x n number of x random samples, and if your population parameter is unknown, because estimation theory of estimation means you are estimating the population parameter. When the population is very large, you are estimating the population parameter on the basis of sample observation or sample statistics. So in interval estimation, we preside two function, like suppose T1 and T2 are two function, and both functions are the function of sample variables. Then if the population parameter is theta, which is unknown, we it may be inside this interval of T1 and T2, and this value, the probability of this theta, probability of this interval of T1 and T2 of theta will have some value, that is 1 minus alpha. Alpha, you know, alpha is the upper highest limit to be in the confidence level, and 1 means the total probability. So we can write that probability of theta in between T1 and T2 is equal to 1 minus alpha, where obviously alpha should be greater than 0 and less than 1. So this interval T1 and T2, this interval T1 and T2 is called the 100 of 1 minus alpha percent confidence interval. This is the 100 in 1 minus alpha percentage confidence interval, the interval T1 T2. That means in between this value, the probability of the probability of of being or lying the population parameter is high. The lower limit T1 is known as lower confidence limit, whereas the T2 is the upper confidence limit. And this probability 1 minus alpha is called the confidence coefficient. This 1 minus alpha, this probability of this is called the coefficient. 1 minus alpha, this probability is known as confidence coefficient. So, uh, so for different distribution, for different population, we have some confidence interval value, so that we can understand in which range this population mean or population variance will lie. For the normal population, suppose x1 to xn be the random sample of size n number of samples are taken from a normal population with mean mu and variance sigma square. That means the population parameter mu and sigma square. If and you are going to estimate, right? So you have to do the interval estimation in which interval it lies. Then here your population parameter are unknown. That means your mean and variance, either two, both are known, or both are unknown, or either any one of the values you know. So if so confidence interval population mean means in which interval your population mean mu lies for normal population when sigma is known. There may be for finding the confidence interval of population mean, there may be two condition. Either you may know the sigma, or you may not know the sigma. So to find out the confidence interval of population mean, that means the mean lies in between which two value, in which what should be the T1 and T2 for population population mean mu, that is to be found out. So when sigma is known, then to find 100 of 1 minus alpha percentage confidence interval for mu for known standard deviation sigma. Just a minute. So when sigma is known, then what should be the confidence interval for population mean? So to find the 100, always we will go for 100% confidence interval. So to find 100 of 1 minus alpha percentage confidence interval for mu for known standard deviation, we know the what is the sample mean, that is 1 by n summation of I equal to 1 to n xi. And for normal distribution, we know that the variance is sigma square by E. Then you know the standard normal variable is equal to root over n x bar minus mu by sigma. This formula already you know. Then your probability of probability of population mean interval will be like this. You will go for Z interval. Since normal distribution is symmetric and Z alpha is the upper alpha point of standard normal distribution, then we can say that this is the Z, this is for a normal distribution. Sorry. This should not touch. So these are the, if this is the 1 minus alpha, if this is the 1 minus alpha, so these two parts, this is these parts and these parts will be the alpha. So this will be alpha by 2 and this is be the alpha by 2, right? So by solving this, we can say minus it will lie, the Z will lie in between this alpha by 2 and minus alpha by 2 and plus alpha by 2, right? So we can say probability of minus Z alpha by 2 is less than equal to this Z value less than equal to Z alpha by 2. It can be written because this is a formula of Z. Then from this, we need only the mu. We need the interval for mu. So we can calculate this for mu. How? Just if you multiply the total with sigma by root n, then it can be x bar minus mu, and this will have sigma by root n. This will be also sigma by root n. And only to get mu, we can write x bar minus this and x bar plus this. So here you can see this is the parameter, population parameter theta in between T1 and T2. In between the two interval. This is the lower limit, this is the upper limit. So we can say the 101 minus alpha percent confidence interval for mu is Z x bar minus Z alpha by 2 sigma by root n, comma x bar plus Z alpha by 2 sigma by root n. So these are the intervals, two interval limits. And if sigma is unknown, and we know for unknown sigma, we can do the distribution or T statistics. So that And in terms of T, this is the formula of T, same as, not same as Z. In case of Z, it is root n by sigma. But in case of T, it is, in terms of sigma, it is sample value, that is S, sample deviation, S. So S by root n, X bar minus mu. And it follows the T distribution with n minus 1 degree of freedom. This part already discussed in the previous chapter. And you know this is the formula of A square. So we can say this T lies in between minus T alpha by 2, n minus 1 to T alpha by 2, n minus 1. For T distribution, the two limits are minus alpha by 2 to plus alpha by 2, and they have n minus 1 degree of freedom. That is why it is written like this. So for one L, we can say this is T alpha triple T alpha. In left side, the lower limit will be minus alpha by 2, and in the upper side, it will be plus alpha by 2. So that is why it is written minus T alpha by 2 to plus T alpha by 2. And this n minus 1 is written just to mention the number or degree of freedom. So as we need only the interval for mu, so we can uh, modify our equation like this. That is, you will multiply this with S by root n into S by root n, and this one is X bar minus mu. So we can write X bar minus mu and X bar plus mu. This is the interval. So that is also, these are all for 100% confidence. That is why this is equal to 1 minus alpha. So the two limits are this and this. These two limits are written, and obviously I already told you this n minus 1 nothing but the degree of freedom for T distribution. And some here an example is given. See, it's very the weight of cement in packed bags is normally distributed. Already it is mentioned, it is normally distributed with a standard deviation 0.5 kg. Again, I'm telling the weight of a cement in packed bag is normally distributed with a standard deviation of 0.5 kg. A sample of 50 bags is picked up at random, and the mean weight of cement is found to be 49.2 kg. So obtain 95% confidence interval for the mean weight of cement bags. So for if you for this you have to find out 95% confidence interval. So you can do this. Already it is written that they needs only 95%. So 100 of 1 minus sigma is equal to 95, because they have given for 95%. So for you can get the alpha will be what? The value of, sorry, this is should be alpha. So 1 minus alpha will be 0.95 and alpha will be 0.5. So this is the value of alpha. So we need minus alpha by 2 to plus alpha by 2. So alpha by 2 will be what? Alpha by 2 will be 0.025. Clear? So this part is not given. That is why I have shown you. So for 95% confidence interval for normal distribution, you got this equation. It lies between X bar minus Z alpha by 2 sigma by root n to this. Why? Because sigma is known here. Just see, the standard deviation is given. Sigma is known. So when sigma is known, so we can go for Z distribution, and that is the formula is this. And you have to remember the formula. So the intervals are this. So Z alpha by 2. So alpha by 2, we got alpha for 95% interval, for 95% confidence interval. alpha by 2 is equal to 0.025. That is why it is written Z 0.025. And this is the formula sigma by root n. Just see the formula, and x bar plus Z 0.025 sigma by root n. Clear? Now, what is the value of Z 0.025? For this, we have chart, and this chart you will get in your, if you have this book, you will get the chart in the in the last pages, in the appendix or like this. So here you see for alpha by 2 0.025, Z alpha by 2 is value is 1.96. So just put the value 1.96 in place of Z of 0.025, and you will get this value. So mu, the population mean, mu lies between this value and this value. So its lower limit is 49.090614 kg to 49.3386 kg. Is it clear? So for this, you have to remember the formula. Is it clear?
Yes, ma'am.
Now, so this we have the idea for finding out the population mean, confidence interval for population mean. Now, the confidence interval for population variance. That means the interval limit of population variance for the known or unknown mu. So in this case, when we find out the variance, we know we have to do the chi-square distribution. So we know this is, if mu is known, so we can write for a known mu, chi-square is equal to this. This formula already known, and this n is the degree of freedom. So as and chi-square distribution is not symmetric. It is not like normal distribution. It is only for first quadrant. The graph is like this. Nah? The graph will be like only for this part. The graph will be for chi-square. So chi-square is not symmetric. It is asymmetric. So the interval for chi-square, the variance interval will be like this. The interval for chi-square is from chi-square 1 minus alpha by 2, comma into chi-square alpha by 2, comma n. Clear? Because it is asymmetric. There is no possibility of minus alpha by 2. You cannot get. So if you have alpha by 2, so the another part will be 1 minus alpha by 2. So this is the limitation. This is the limitation of chi-square, and it is for 100% confidence interval. We can write the probability of this is equal to 1 minus alpha, and we have to find out the sigma square, because we are finding out the confidence interval for population variance. So from this, we will find out for sigma square. So finally, sigma square will be in this range. The sigma square will be in this range. And so the two limits, the lower limit is this and upper limit is this. Just see how it is done. You can see from later on. And chi-square, and this is the chi-square distribution interval. And if this is for mu, known mu, and if you have mu unknown, then you can do in this way. When if mu is unknown, then we can use this formula, that is chi-square is equal to in a square by sigma square, when where mu is unknown, because here mu is known. That is why we are doing in this formula, that is xi minus mu the whole square by sigma square. But when mu is unknown, then we can replace this formula with capital S square. And finally, the interval will be n a square by chi square alpha by 2 comma n minus 1 to n square by chi square 1 minus alpha by 2 n minus 1. This formula, please, you in home, you please write many times so that you can remember all those formula. And for the population proportion, how to find? For the population proportion, you know this formula Z equal to P minus pi root over pi into 1 minus pi by n. And because pi is one of the parameter for binomial population distribution, and you know that if pi is not known in general, so it can be estimated with the symbol p, because p is the proportion, right? So based on the above distribution, we can obtain this 101 minus alpha % confidence interval also, and that is nothing but probability of minus z alpha by 2 to plus z alpha by 2 with p minus pi by, if pi is not known, then we can write in terms of pi, we can write p. So p into 1 minus p by n. And finally, as we have to population proportion, so we have to find out in terms of pi. We have to find out the limit of pi. So from this equation, you will get the interval of pi is in between these two limits. The interval of pi is in between these two limits. And if your population size is known, you can write this modified equation in this way. And there is some examples is done here. So you will see these examples in your home. And I have in the morning I have sent you one notes, one solve some solution of this chapter. So you please go through this chapter so that many questions are solved here. It may help you. I will discuss some of the question from this. It may happen that the solution is not correct. Sometimes mistakes may happen. So you just do according to yourself. The procedures are given. You can have different. In the last lecture, we got some equations, and those derivation also done in here. So now see some of the question, because in for your exam purpose, different problem solving is the main thing, because you may get the questions to solve. So you have to know the problem solution, how to do it. So see, so this is the first question. Here it is written that if x1, x2 to xn be a random sample drawn from a normal population with mean mu and known variance sigma square, then what will be the 95% confidence interval, what will be the value of mu? That means what was the in range of p. So for 95% confidence level, okay. So here sigma squared is known. So for sigma squared is known, we can go for this equation. For sigma known or sigma squared known, we can go for this formula. That is, mu lies between x bar minus z alpha by 2 sigma by root n to x bar plus alpha by plus z alpha by 2 sigma by root n. So this is the formula x bar. You know this formula that it lies between x bar plus minus z alpha by 2 sigma by root n. Now 95% confidence intervals are maintained. So you see that 100 of 1 minus alpha %, this percentage is, they have given 95%. So we can write 100 of 1 minus alpha % equal to 95%. So from here, we can calculate the alpha. And we need alpha by 2. So alpha by 2 is 0.025. So Z alpha by 2, the formula Z alpha by 2, Z 0.025 is equal to 1.96. So put the value 1.96 and then you will get X bar. They have given this option, so we can give that X bar plus minus Z 1.96 sigma root over n. If they have given all these value of n, root n, X bar, that means the sample mean, then you can finally find out the range in terms of value. Then another question we may solve. This parts I am not giving you. It's on MCQs. You can solve yourself. Next question is assuming the normal, assuming the normal distribution. Suppose that a 95% confidence interval for mean is 50, 60. That means they have given you the interval for 95%. So what will be the possible interval for 99% confidence? They have given you the interval, given you the limit for 95% confidence interval. Then what will be for 99%? That is the question. Then what will be the limitation limits for 99 confidence level, 99% confidence interval? So for that, just see, uh, for 95%, the limits are 50 to 60. So we can, here to find out the 99% confidence interval, we should know the value of, this is normal distribution, so we should know the value of X bar, the value of sigma, root n, like all these unknown factors we should know. So from the given interval, we can get two equations using the variables X bar, sigma, root n. Because we know this is the formula, the limitation should be X bar plus minus 1.96 sigma by root n. So for 95% interval, alpha by 2 equal to 0.025, so it is 1.96. So we can write like this, that is X bar minus 1.96 sigma by root n. This Z alpha by 2 is put from this value, sigma by root n, that is equal, this is the lower limit. If we take the minus, then X bar minus this is the lower limit. So lower limit is given 50. So I have written 50. Next one is X bar plus 1.96 sigma by root n, that is 60. Upper limit 60. So by solving these two equations, we can get X bar and we can get the sigma by root n. This total factor we can find. So now for 99% it is easy, because for 99% alpha is equal to 0.01. So alpha by 2 will be 0.005. Then for alpha by 2, 0.005, what will be the value of Z? Z alpha 0.005 is 2.576. So we can write it is 2.576. And finally, we can put this value here, and X bar is also known. Then we can get this interval, that is 4862. So this option is correct, 4862. So in this way, we can find out the interval. Another question is here, just see if X bar is the mean of a random sample of size n from a normal population. So same type, from normal population, you know how to, what is the formula, and whatever value they need, just put it and find the number of sample. So here number of sample which they need in. So we'll get in from the equation. So different types of questions are solved here. Let me see, check another type of question based on the, these are, I'm not showing here because these are the derivation of equations. So already it is done in, it is a theoretical part. So I'm not going. So I'm going for problem solution. Another question is, if the variances of two unbiased estimators T1 and T2 are same, that means the sigma squares are same. Variance of T1 and variance of T2 are same. Then which of the this and this is the minimum variance unbiased estimator of theta. So we have to find out the variance of those these two case and find out whether it is unbiased estimator of theta or whether it is minimum, which one is minimum, you have to find out. So variance of T1 plus T2 by 2. So find out variance of T1 plus T2 by 2 is 1 by 4 variance of T1 plus variance of T2. So that is equal to 1 by 4 sigma square plus sigma square, that is 2 sigma square. So 2 by 4, it will be 1 by 2 sigma square. Here it is written wrong. It is not 1 by 4, it is 1 by 2. Because 2 sigma square you are getting. So 2 by 4, that is 1 by 2 sigma square. Another is variance of T1 plus T2 by 4. And it is constant. So if you take out from here, it will be square, that is 4 square. And this will be variance of 3 T variance. This is also 3, 3 means 9. 9 sigma square, and this is also sigma square. So 9 plus 1, 10 sigma square by 16. That will be 5. It is 5 by 8 sigma square. So you are getting 1 by 2 sigma square and 5 by 8 sigma square. Then see which one is minimum. So that will be the minimum variance unbiased estimator of theta. And here another question is also given. If T1, T2 and T3 are three statistics with expected value of ET1 is this, ET2 is given, ET3 is given, so find unbiased estimator of theta. So three equations are there, so you take any of two and equate those. Finally, you will get the value of theta 1, theta 2, theta 3. So this is theta 1, theta 2, theta 3. So unbiased estimator of theta 1, theta 2, theta 3 will be this, and this. These are easy questions. Here a question is this, that a random sample of 100 days show an average daily sales of rupees 5,000. So what is given? Number of sample, that is sample size small n is given. Then average daily sales of rupees 5,000. So for sample, average means X bar. Sample mean is given with standard deviation of rupees 1,000. So sigma is given in a particular shop. Then assuming a normal distribution, construct 95% confidence interval for the mean sell per day. So you have to find out the confidence interval for mu. So you know the value for mu, mean, that is X bar plus minus Z alpha by 2 sigma by root n. And 95% confidence interval means similar way. You will get alpha by 2 equal to 0.025. So 0.025 is 1.96. So put the values. All the values are given. Put those values and we'll get the interval. Next, you see this question, a random sample of size 500 selected from a large lot of machine parts where 7% are defective. What informations can be inferred about the percentage of defective in the lot? So here number of samples size, that is sample size is 500 is given. So P is the sample proportion of defective, that is 7%. So standard error of P will be this. Just put this value. P means 7% means 0.07, 7 by 100, 0.07 into 1 minus P, and sample is 5. So you will have this value. And so for 95% confidence limit will be like this. This is the confidence limit for population proportion for 95%. That is P plus minus Z alpha by 2. Standard error of P. So that will be the actually Z alpha by 2 into root over P into 1 minus P by N. So in terms, it is written here, and you just put this value, you will get this to limit. And so for 99% also in same way, similar way, you can get the limit. So here some questions on the proportion is given. These questions are all and in the same on the based on the same theme. Okay. So I think all of you have these notes. You please go through this, and if you get any, uh, if you're stuck in this, I can help you. You can call me. You can WhatsApp me. So, do you have anything related to this? Do you have any queries related to this lecture? Then you can tell me. Is there any queries?
ম্যাম এই নোটটা কি শেয়ার করা আছে ক্লাসরুমে আপনার এই
ক্লাসরুমে
সাজেশন?
শেয়ার করা নেই। আমি আমি তোমাকে শেয়ার, আমি তো আজ সকালবেলা হোয়াটসঅ্যাপে শেয়ার করেছিলাম
আমি গ্রুপে
দীপানুরাগ
পাঠিয়ে দিয়েছি।
চক্রবর্তীর সঙ্গে। ও
আমি গ্রুপে
পাঠিয়ে দেবে
পাঠিয়ে দিয়েছি।
সবাইকে।
আচ্ছা আচ্ছা ঠিক আছে।
পাঠিয়ে দিয়েছি ম্যাম বলে।
আচ্ছা আচ্ছা।
ও আছে
তাহলে
নবনীতা দিকে
তোমরা
দিতে হবে।
ওখান
হ্যাঁ
থেকে
দিয়ে
পেয়ে যাবে।
ফরওয়ার্ড করে দেবো।
হ্যাঁ, দেখো কোয়েশ্চেনে অনেক সময় তোমার সব কোয়েশ্চেন যে ঠিক হবে তাও না। যদি কোনো জায়গায় মনে হয় যে এটা আমরা ভুল আছে, এটা এটা হবে, তাহলে তোমরা সেটা করে নিতে পারো। আমার কোনো অসুবিধা নেই, আমাকে একটু জানিয়েও দেবে। ঠিক আছে, ঠিক আছে। তাহলে মোটামুটি আমাদের আজকে মোটামুটি শেষ হয়ে গেল। যদি আর কোনো ক্লাসের দরকার হয় তোমরা আমাকে বলো। For your upcoming semester exam, please do practice and keep practicing, keep notes and the chapters, because so many questions are there. You have to, if you have the perfection, if you have to practice more. Clear?
Okay, ma'am.
Okay,
So with your permission, may I leave now?
থ্যাংক ইউ ম্যাম।
Welcome.